Now it's my great honor to introduce our last speaker for our plenary talk. It's Professor Alan Winfield. Alan is a professor of robot ethics and the director of the Science Communication Unit at the University of the West of England. He's also an associate fellow of the Center for the Future of Intelligence in Cambridge, and he co-founded the Bristol Robotics Laboratory. And additionally, apparently, Alan is a very active blogger with a blog that reaches back like 16 years with hundreds of blog posts, which is very interesting to read. It's about robotics and ethics in general. So I'm really looking forward to your talk. Thank you very much for agreeing to be our plenary speaker, and the stage is yours.
Thank you very much indeed, Jan. Well, firstly, let me say what an honor it is to be invited, and I'm like the previous speaker, I'm very sorry that I couldn't be there in person. But what I'd like to present to you is an ethics dimension, if you like, which I think was what you were hoping for from me, and suggest a direction towards a responsible soft robotics. So in other words, you're probably all familiar with the idea of responsible robotics. So what I want to try and do is to tailor that vision to soft robotics. So what I'm going to do is to start with a very broad introduction to responsible robotics, and if you like, the where we are now, because we're in a good position in responsible robotics in the sense that we already have quite a sophisticated set of they're relatively new tools for practicing responsible robotics, and I'll reference some of those tools, and then towards the end of the talk I'll focus on soft robotics, and in particular sustainability, which I think is something that soft robotics will be able to bring to responsible robotics that, in a sense, I think traditional hard robotics has difficulty with. So what is robot ethics? Well, it's concerned with the ethical impact of robots on individuals, society, and the environment, and how to mitigate any negative impacts. In practical terms, that means that we are concerned with how human designers, manufacturers, operators, and maintainers should act in order to address those ethical impacts. Of course, we need to figure out what the ethical impacts are, and I'll come on to that. We do actually have tools for doing that already. So what is responsible robotics? Well, we define it very simply as the application of responsible innovation in the design, manufacture, operation, repair, and end-of-life recycling of robots that seeks the most benefit to society and the least harm to the environment. Now, responsible innovation is an existing set of ideas, and I'm sure you're all familiar with responsible innovation in your research. It's something that is not an option. Anyone nationally and internationally who receives research funding will have to sign up to doing responsible innovation. So I'm sure you're already familiar with frameworks for responsible innovation. So accidents happen. Clearly things go wrong with robots, and that's been true for many years. In fact, what I did here was I pulled up the database, a listing from the US Department of Labor search on accidents with the keyword robot. And you can see here is a little bit of data that comes up. The X in the column means it was a fatality. So these are serious accidents. And these are, of course, industrial robot accidents. So something that accidents that have been going on for, well, since the 1960s, in fact. So robot accidents are not new. That's something that's very clear. What is new, of course, is accidents with autonomous robots, and in particular, here's a tragic but also a dramatic example. The very first fatality, or at least known fatality, of a Tesla in autopilot mode. The unfortunate driver was not paying attention at the time of the accident. He was not paying attention to what was going on, and in fact, a trailer, which you can see in this diagram from the National Transport Safety Board accident investigation report. A trailer crossed right in front of the car, and the car literally drove underneath this trailer, and then which ripped off the roof of the car, and the car ended up quite some distance away in a field, so it was traveling at some speed. And this was clearly a failure of both the AI, because it failed to recognize this white trailer. It thought it was sky. If you like, it was a perception failure, but also a failure of the driver who was responsible not paying attention. Social robot accidents also happen. We tend not to see them very much in the press because they're not as widely reported as, for instance, driverless car accidents. But here is one that happened to make the, excuse me, the national press in the US. A security robot which collided with a child and caused a minor injury happened to be reported. But in general, with social robots, we tend not to know about accidents because they're not reported. They're not required to be reported in law in the same way as industrial robot accidents. So how can robots cause harm? Well, obviously there are, the traditional first category is physical harm, but we need to add a set of ethical harms to those, to physical harm. And those harms can broadly be characterized as psychological harms, and which is a very long list of actual hazards: robot deception, over-dependency, over-trusting. Arguably, over-trusting is precisely the thing that that the driver of that Tesla was doing, over-trusting the robot, the AI. Of course, there are societal harms that we're familiar with: loss of privacy, loss of jobs, and such like. And of course, importantly, environmental harms, high energy costs, unrepairable or unrecyclable technology. And in fact, there is a really nice database, crowdsourced database, which if you haven't come across, I do recommend. It's called the AI Incidents Database. And it importantly includes not just accidents, but also incidents. In other words, near-miss accidents. And of course, near misses are just as important in terms of safety and ethical safety as actual accidents, because we can learn a lot from near misses. So what I want to do now is to give you a sense of where we are in ethics and the various tools that are beginning to emerge. So in this paper, which my research colleague and I wrote back in 2018, Ethical Governance is essential to building trust in robotics and AI systems. We suggested that from a foundation of ethics, ethical principles, standards will emerge, and indeed they are emerging, and standards underpin regulation. Now, I don't have time to talk about all of this in very much detail, but I will just discuss some of the emerging ethical standards in this talk, because they're important parts of the toolkit. So standards, as I've argued, are infrastructure. They're a kind of invisible infrastructure I think absolutely vital to the modern world, no less important than physical infrastructure like telephone networks and roads and airports and such like. So they are really ubiquitous. And just to give you an example, there are two standards, ISO standards for toothbrushes. 2162 is manual toothbrushes like this one. 2127 is electric toothbrushes. There's a standard also, ISO 11609 for the toothpaste, and of course, a standard for the quality of the water that you use to rinse out your mouth after you've brushed your teeth. So actually, when you brush your teeth, there are 4 standards at work. Well, 3 actually, because you won't use both a manual and an electric toothbrush at the same time. So standards really are ubiquitous. And it was only when I got involved in standards work about, I guess about 10 years ago, that I realized how important standards are. And in 2019, I was invited to publish or to write this short comment article. And if you want to understand, if you like, the background to ethical standards in robotics and AI, do please have a look at this paper in Nature Electronics. So I'm now going to talk about 1 or 2 of those standards. And in particular, I'll start with the IEEE Standards Association, who in 2016 launched its global initiative on the ethics of autonomous and intelligent systems. And in particular, they're looking to intelligent and autonomous systems advancing for the benefit of humanity. So this is a really ethically rooted initiative. And since the initiative was launched, we published this crowdsourced document called Ethically Aligned Design, which I recommend you download and have a look at. It's essentially a set of ethical issues and recommendations, quite a lot of them, in fact. I think around 150 ethical issues. So it really is a very broad and comprehensive approach to what we call ethically aligned design. But of course, because the IEEE Standards Association is exactly that, a standards association, a number of so-called human standards were launched at the same time, or more or less at the same time that we were developing ethically aligned design. And in fact, several of them, here are 5, I think it's probably now 6 of these standards have been completed and published. And I won't go through these in detail, but you can see the kind of key words that really do pick up a number of the big ethical issues in robotics and AI that the world faces. So the fact that standards are emerging, I think, is really, really good news, really good news. And I just want to focus a little bit on the standard that I led, which is IEEE 7001 2021, which is a standard on transparency of autonomous systems. We believe it's the world's first technical standard on transparency. And again, I think it's I really want to pay tribute to the working group which I led to really bring this to publication in 5 years of hard labor was quite something. So why is transparency important? Well, as I've already illustrated at the beginning of the talk, autonomous systems, robots can and do go wrong. And when they do, it's very important that we find out why. And without transparency, finding out why, and therefore making sure it can't happen again, is extremely difficult. And of course, all autonomous systems, all robots are designed to work with, for, or alongside humans. And of course, we need to be able to understand what they are doing and why. And without that understanding, we really will not have confidence in those robots. So transparency, I think, is essential for these things. Now, transparency is not one thing. And in fact, in 7001, we actually organized the standard into 5 sections, where each section is targeted at a different stakeholder, because each of these stakeholders needs a different set of measures for transparency. Transparency is not the same for safety certification engineers, or for accident investigators, or for lawyers or expert witnesses, or indeed for users and wider society. So each one of these stakeholder groups has a different set of measurable, testable levels of transparency. And I'm not going to go into these in very much detail, but I will just mention accident investigators. Well, what information does an accident investigator need to find out why an accident happened? Well, obviously details of the events leading up to the accident, and of course details of the internal decision-making processes in the robot's AI, the autonomous systems decision-making processes. And of course, we have a very good model of best practice, which is the processes of air accident investigation. And in particular, of course, part of that good practice is the flight data recorder, which is equipped, fitted as standard. It would be illegal to fly an aircraft, certainly commercially, without a flight data recorder. So we can make use of that, if you like, copy that best practice. So 7001 also defines 2 sets of processes. The first we call system transparency assessment, which is a method for assessing the transparency, literally measuring the transparency of an existing system. And the second process is called system transparency specification. That should see, the acronym should be STS. And it's a method for specifying the transparency requirements of a system prior to its development. And in this paper published in 2021, you can read about the background to the standard, the background, the thinking behind the standard, including illustrations of these 2 processes. Now I'm going to turn to the next thing in our toolkit, which is accident investigation. In fact, I have a project, a current project led from the University of Oxford on exactly that, on robot accident investigation. And in fact, we are developing what we call an ethical black box. We first made the case back in 2017 that all robots, and especially social robots, and of course that includes soft robots, must be fitted as standard with the equivalent of an aircraft flight data recorder. And we call that an ethical black box, simply because it would be irresponsible not to have one. So we're currently developing this as part of the project, and Jan very kindly referred to my blog, and you'll find blog posts about the development of the ethical black box. But of course, accident investigation is a human process. You need the data, of course, but you also need forensic evidence, you need witness testimony, and so on. And so a unique aspect of this particular project is, and I believe we're the first in the world to do this, we're staging a number of mock accident scenarios. And those 3 scenarios are assisted living robots, educational toy robots, and actually driverless cars. It says driverless cars here, but we're now thinking we're going to switch that to smart prosthetic devices. And the important thing here is that we have human volunteers as both subject of the accident. Of course, nobody's harmed. These are play acted. Witnesses to the accident, and the witnesses have no briefing beforehand, so they don't actually know what's happening. And of course, members of the accident investigation team, who also do not know what has happened. And in fact, the first one of those mock accident scenarios has already taken place. And here are just a few photographs of the pilot mock accident investigation in April of this year. Of course, all of these were delayed, deferred because of the pandemic. but we made use of our assisted living studio in the Bristol Robotics Lab, which is, if you like, a fully equipped kind of granny flat, elderly person's apartment. So we think that accident investigation is an absolutely essential feature of the toolkit of robotics, of responsible robotics. Now, I'm now going to turn to another standard that in fact, the first standard that I was involved in, BS 8611, because this, I think, has particular relevance to soft robotics. So what is BS 8611? Well, it's a method for doing ethical risk assessment. Now, what ethical risk assessment does is essentially the same as old-fashioned risk assessment. In fact, I'm an old-fashioned safety critical systems engineer, so I'm very familiar with risk assessment. It's essentially what safety engineers do, but by extending the envelope to cover ethical risks. In other words, the kind of harms that I outlined earlier, psychological, societal, and environmental. So ethical risk assessment is extending the envelope. And here are some definitions of what we mean by a harm, a hazard, and a risk. A harm is that might compromise psychological and/or societal and environmental well-being. A hazard is a possible source of harm, and a risk is a possible harm arising from exposure to a hazard. These are definitions from the standard. So I'm going to consider a worked example of a soft robot, a fictional robot toy called RoboTed, and this was published actually in 2 papers, and this is the more recent paper, Ethical Risk Assessment for Social Robots, Case Studies in Smart Robot Toys. And that more recent paper covers one fictional robot, which is RoboTed, and the other real robot, a robot called Purble. So in ethical risk assessment, what we do is that we break down and assess the ethical risks under a set of categories. And I don't really want to go into the psychological risks because I don't have very much time, but you can see the kind of hazards: addiction, deception of the child, over-trusting by the parents, and the uncanny valley. But what I really wanted to do was to share with you the environmental risks, because I think this is of particular salience to emerging techniques in soft robotics. So the ethical risks of the environmental risks, rather, for RoboTed are the sustainability of the materials. So the risk is that robot uses unsustainable or high carbon cost materials. So the mitigation is that we use materials from sustainable sources, avoiding plastics. We could make the skeleton of RoboTed out of wood, for instance, which would be a highly sustainable material. And then repairability. Unrepairability is a big hazard and would limit the robot's lifetime. We need to design for ease of repair, especially with replaceable parts. And importantly, and this should be true for all electronics, of course, not just robots, but the repairs should be capable of being carried out by a local workshop. So, the right to repair, I think, is an important part of our addressing, small part, of course, of our addressing the climate emergency. And of course, unrecyclability is also an issue for robots, and especially, of course, for traditional hard robots made out of metals and plastics. So I also want to mention energy, because energy sustainability is just as important as material sustainability. And you might be interested in work that we've been doing for many years in the Bristol Robotics Lab on building robots that can eat food. And these are pretty sustainable robots. EcoBot 3, for instance, the tall one here, which actually has a set of, I think, 48 microbial fuel cells. These are small cells that essentially can digest organic material and directly generate energy, electrical energy, which is stored in supercapacitors. Again, I don't have time to talk in detail about this, but the whole of this robot is highly sustainable because all of the plastics are recyclable. They're all 3D printed and can be melted down and completely reused. The only bit that's not recyclable easily is the electronics. And of course, it's highly energy sustainable because the robot is not running on traditional batteries, not using rare materials, at least for the batteries. And I think an example of energy sustainability. So really, I just want to finish by explaining or telling you that there is a new standard, British standard in development. It's called A Guide to the Sustainable Design and Application of Robotic Systems. And I believe that this new standard, when it's published, we're only about 6 months into writing this standard, will be really important to robotics in general, but I think especially salient to soft robotics. And essentially, the standard is setting out requirements for robots to be made from sustainable materials, to be energy efficient, to be repairable, and to be recyclable, and some other things. Those are just the 4 kind of key headlines. And again, you could read a little bit more about this on my blog if you're interested. So that brings me to the end of this keynote. But in conclusion, I really want to say that I believe soft robotics has huge potential to extend the envelope of responsible robotics to encompass truly sustainable robots. Sustainability that really is very difficult to achieve with traditional, if you like, hard robots. So I think that there is an extraordinary opportunity for soft robotics. And that's really why I'm suggesting towards a responsible soft robotics, which goes beyond the kind of responsible robotics that we should indeed be doing anyway, with all robotics, not just soft robotics. So thank you very much indeed. Thank you.
Thank you so much, Professor Winfield. That was a great talk, but with very valuable points for us as designers of these systems, I would say. So there were so many things that I haven't thought of before, like having this black box, for robotics, which makes so much sense, right? If we have robots, out in the world, and we later on want to know what happened, there should be something like this later on implemented. So that was very, very interesting. Still want to give the opportunity to everyone, if there are questions for Professor Winfield, you can definitely come up and ask these. In the meantime, please, if you have questions.
Yeah. Of course, I'd be delighted to, if anyone wants to contact me directly, email me, and to ask questions, of course. I'd be very happy to answer offline.
Okay, so I will certainly contact you again after these questions, because so a super interesting talk. I'm very in my research, I want really to be oriented in that way. So very interesting. So I had 2 questions. One, but we are not obliged to tackle the 2 questions right now. But the first one is about this black box. The question of what information we should register, because I guess it would be a feedback with the ethical process of what information is interesting. So I wanted to know if you had, about this process, some insights to give. And then for the sustainability aspect, you spoke about material, repairability, etc. But I guess, what do you think about doing this whole life cycle assessment, which takes into account, in addition, energy consumption, fabrication process into the the carbon evaluation? Let's say.
Thank you. They're 2 great questions. So the first, in response to the first question, in fact, we published a few months ago. Actually, I think it was last summer, draft 0 of an open standard for the ethical black box. It's on Archive, and if you check my blog, you should be able to find it fairly easily, or you could email me. And that really sets out the first draft. The point is that it's, you can't possibly write a specification that's going to be right first time for what should be recorded, what should be captured by a robot. But there are certain things that you would expect to be captured. So sampled sensory data, so you know what the robot's sensing. Also, obviously, actuator data, what are the actuator demands? And of course, very importantly, also the internal decisions that were made in order to, as the robot is running. And of course, when robots are interacting with humans, then there are interesting ethical debates about to what extent should the ethical black box capture the human interactions with the robot, because clearly they are highly relevant to an accident such as the ones that we've been conducting in our lab, the mock accidents. So now, as to your second question, well, in fact, the standard 8622 that is currently in draft is absolutely looking for a complete life cycle assessment in some detail, because we need to consider the sustainability not just of the robot itself, but for instance, the operational infrastructure, all of the stuff that typically robots need to be able to do their job. We need to look at, for instance, the environmental impact of the robot while it's actually operating, not just at the end of its life, but when hopefully we can repurpose, upcycle, at the very least, we can recycle. But we need to consider all of those things, and of course, there's an environmental cost in building robots in the first place. I mean, bearing in mind, of course, it's well known that the environmental cost of motor cars is primarily in their manufacture. So even when you drive a motor car for years, you generally do not use as much energy as the cost of building it in the first place. So we need to make sure that if robots are to be truly part of the, as I often put it, in the climate emergency, if you're not part of the solution, you're part of the problem. And I'm sorry to say that right now, robotics is part of the problem. And I'd like it to be part of the solution. So I think it's really important. And I think you guys in soft robotics, and we have a big soft robotics group in my lab. So I know a bit about soft robotics, but I don't work in the field. But you guys, I think, have a fantastic opportunity to make robotics part of the solution.
Super, thank you a lot. And I agree, and I think it could lead to very interesting research topics without being a negative constraint necessarily. So thank you again.
Thank you. Thank you.
Hey, thank you for this question. So we have one last question, I would say. And yeah, please go ahead.
Thank you for this talk. In the beginning of the talk, you made quite a profound statement, and I wonder if you can elaborate a little bit more about where you mentioned standards are infrastructure. And in addition to this, if you can also say what are some of the standards that you think we should have, but we are not currently having? Thank you.
Oh, that's a great question. Yes, I mean, how can I? Yes, I mean, I think they are infrastructure. After all, I could not be talking to you now without a whole bunch of standards. And the room that I'm looking at, the very nice room that you're all sitting at, well, there are standards for everything. There are standards for the quality of the materials, the fire safety, for the lighting, for the microphone that you've just spoken at, almost everything. I mean, you've all got devices with Wi-Fi. Wi-Fi is a fabulously successful standard. There are standards, of course. I mean, we're talking via the internet. Well, the internet itself is built on a set of very famous open standards, remarkably open standards. And without all of that stuff, we would not be able to have this kind of conversation. So, that's why I make this claim that standards are infrastructure. Now, as for standards that we ought to have that we don't have at present, I'm going to have to think about that one. I mean, the standard a year ago, I would have said we need a standard on sustainability. Well, happily, we're now writing one. I mean, it's obviously going to take several years. And one of the problems with standards, of course, is they take a long time. I mean, they are carefully written documents by volunteers. That's also worth mentioning. All of these standards that we rely on are written by this vast number of volunteers. Typically, if you're a member of a working group, you're not paid anything at all. So it's a voluntary work. So I would say, please get involved in standards. Please do volunteer to become involved in standards. But I'm afraid I can't give you a quick answer to the which standards are missing, because the ones that I would have mentioned, I think we are in development. Thank you.
Okay, thank you so much. Let's thank the speaker again.
Thank you. Thank you.